Hi all, welcome to this session. I am Dr.R.RADHIKA from S.A.ENGG.COLLEGE, Department of Electronics and Communication Engineering. In this session, we discussed about the Boolean algebra. Boolean algebra is the category of algebra in which the variables values are the truth values, either true and false, ordinarily denoted as 1 and 0 respectively. True is mentioned as 1, false is mentioned as 0. It is used to analyze and simplify digital circuits or digital gates. It is also called binary algebra or logical algebra. It has been fundamental in the development of digital electronics and is provided for in all modern programming languages. It is also used in set theory and statistics. The important operations performed in Boolean algebra are conjunction, disjunction and negation. Hence, this algebra is way different from elementary algebra, where the values of variables and numerical and arithmetic operations like addition, subtraction is being performed on them. So first we discussed conjunction, called as an AND operation. Disjunction is called as an OR operation. Negation is called as a NOT operation. So conjunction and operation, the set represent the intersect of the two elements. And then disjunction or operation, combination of all the things. And this one is negation, the rest of the things. A logical statement that results in Boolean value either be true or false is called as a Boolean expression. The synonyms are used to express the statements such as yes for true and no for false. So 1 for true, 0 for false. Boolean expressions are the statements that use logical operations and or not XOR. Thus, if we write x and y is equal to true, then it is a Boolean expression. So x is one variable, it performs some operation that is called AND operation with y, and it produces one result, that is, the result is true. X and y is equal to true is called a Boolean expression. So Boolean algebra is the branch of algebra that deals with logical operations and binary variables. Boolean variables, the variables which involved in that Boolean expression. A Boolean variable is defined as a variable or a symbol, defined as a variable or a symbol, generally an alphabet that represents that logical quantity such as 0 or 1. Boolean function consists of binary variables, logical operators, constants such as 0 and 1 equal to the operator and the parenthesis symbol. Literal, complement, truth table. A literal may be a variable or a complement of a variable, x or x bar. Complement is defined as the inverse of a variable which is represented by a bar over the variable. So x is a literal, x bar is also a literal, it is called as a complement. Truth table is a table that gives all the possible values of logical variables and the combination of variables. It is possible to convert the Boolean equation into a truth table. The number of rows in the truth table should be equal to 2 power n, where n is the number of variables in the equation. This is if 3 variables are used, x, y, z. How many combinations are involved in this 3 variables means 2 power 3. 2 power 3 means 8 combinations. So 8 combinations are mentioned in the truth table. There are 6 types of Boolean algebra laws: commutative law, associative law, distributive law, AND law, OR law, inversion law. The commutative law is the A dot B is equal to B dot A. So the exchange of the variables does not affect the expression. A plus B is equal to B plus A. See, any binary operation which satisfies the following expression is referred to as a commutative operation. The following expression is A dot B is equal to B dot A. Commutative law states that changing of the sequence of the variables does not have any effect on the output. That is commutative law. Next one is associative law. A dot B dot C is equal to A dot B dot C. So the expression is interchanged, but there is no effect in the output. It states that the order in which the logical expressions are performed is relevant as the effect. Distributive law states the following conditions: A dot B plus C. Here the sign is changed. A dot B plus A dot C. A plus B dot C. A plus B dot A plus C. And AND law. These laws are used for the AND operation. So A dot 0 is equal to 0, A dot 1 is equal to A dot A is equal to A dot A bar is equal to 0. Next one is OR operation. So these laws use the OR operation, therefore they called OR laws. A plus 0 is equal to A plus 1 is equal to 1, A plus A is equal to A plus A bar is equal to 1. If the tautology and fallacy, if the output of Boolean expression is always true, is called a tautology. If the output of the Boolean expression is always false, that is 0, it's called fallacy. So let us discuss some practice questions. Consider a Boolean gate D where the output Y is related to their inputs A and B, as Y is equal to A plus B dash. B dash is nothing but B bar, where plus denotes logical OR operation. The Boolean inputs 0 and 1 are also available separately. Using instances of only D gates and the inputs 0 and 1, it may be NAND logic can be implemented, OR logic cannot be implemented, NOR logic can be implemented, AND logic cannot be implemented. Here there are two options. NAND logic can be implemented, NOR logic can be implemented. So sometimes in gate question paper, they give two options as an answer. The minimum number of 2 input NAND gates required to implement a 2 input XOR gate is 4. So the NAND gate and NOR gate are universal gates. So using this NAND and NOR gate, we can able to implement all the remaining gates, AND, OR, NOT, XOR, XNOR like this. So to implement a 2 input XOR gate using a 2 input NAND gate, we require 4 NAND gates. The output of the combination circuit given below. So this is a combination circuit which consists of AND gate, XOR gate. So in this, B, C plus A is an answer. So A and B, and then B and C is the result of these two things. And then this output is given as an input for AND gate and XOR gate. The output of AND and XOR is given as an input for the next XOR gate. We get an answer B, C plus A. So in the given figure, the output is required to be Y is equal to AB plus CD bar. The gates G1 and G2 must be, this question is asked in 2015, NOR gate, OR gate, because they mentioned as G1, G2. Either the gate may be a NOR or NAND, NOR or AND NAND. So the answer is NOR and OR. So we get an answer as AB plus CD whole bar. In the circuit shown, diodes D1, D2 and D3 are ideal, and the inputs E1, E2, E3 are 0 volt for logic 0 and 10 volt for logic 1. What logic gate that the circuit represent? The circuit represent 3 input AND gate. So here this is a representation for 3 input AND gate because there are 3 inputs E1, E2 and E3. In the circuit shown in the figure, if C is equal to 0, the expression for Y, this question is asked in 2014. So here is a circuit, and then C is an input for inverter, AB is an input for NOR gate, and same AB is used as an input for this, and we get the result as Y is equal to AB bar plus A bar B. So this is an XOR gate. A bulb in a staircase has 2 switches, one switch being at the ground floor and the other one at the first floor. The bulb can be turned on and also can be turned off by any one of the switches, irrespective of the state of the other switch. So it depends on the same one switch, does not depend on the other switch. The logic of the switching of the bulb resembles an XOR gate. A bar B plus A bar B, A B bar. The output Y in the circuit below is always 1. So the output is always 1 means what may be the option? 2 or more of the inputs P, Q, R are 0. 2 or more of the inputs P, Q, R are 1. Any odd number of the inputs is 0. Any odd number of the inputs is 1. 2 or more of the inputs P, Q are 1. So if 2 or more of the inputs P, Q are 1 means the output is 1. For the output F to be 1 in the logic circuit shown, the input combination should be, this question is asked in 2010. So the answer is A is equal to 0, B is equal to 0, C is equal to 1. So this is XOR gate, XNOR gate. For the ring oscillator shown in the figure, the propagation delay of each inverter is 100 picosecond. So what is the fundamental frequency of the oscillator output? 1 gigahertz. So because this is given as a 100 picoseconds, all are in series. Thank you.